Hello students. Now in today's session of microprocessor and microcontroller, we are going to discuss about the continuation of Unit 4, that is the AVR assembly language programming. Right now in this session we are going to discuss on the topic that is AVR assembly programs related to various instruction set which we have seen in the previous lectures and the IO port programming. Right, so in today's session basically it is converted, or it is based on the programming language and how you can write different assembly language program on this particular instruction area set for ATmega32. So let's start with the different programs given as per the program instructions. Right, so we will going to see each different programs based on the instruction set. Now, so based on this, first program having the statement that is write a program to toggle all 8 bits of port B forever with the time delay between on and off states. Right. So what does this statement tells about? That we need to toggle all the 8 bits of port B. That means we need to take first of all data as a let's say port B has some data and we need to show that data need to be toggled. Toggle, that means nothing but the complement. If it is 1, then it should be a 0. Right, so what we need to do is we need to see that particular data on the output port. Right, and then we need to toggle that particular data, and when then that toggle data we need to send on the again port B. Right, so this for this port B will becomes the output port. So for making an output port, what is the solution of the program is? First, let's talk about the first two instructions in the solution. So the first instruction, that is LDI R16 0xFF. So FF, that is in hexadecimal, that becomes 8 ones. So all the 8 in R16, that is register 16, is loaded with this 0xFF, which is in binary is shown as 0B and 8 ones on the right hand side. Now next instruction, that is out DDRB comma R16. Now what does this out instruction will do? So it will provide this R register data into that output port, which is DDRB. Now DDRB, as we have discussed in the IO port programming, right, IO port session, that DDRB, when we talk about the DDRB, the DDR stands for the data direction register. So it will show, or it will direct that particular port is working as the input port or output port. Right, so whenever we need to make that port as an input port, then we need to set in particular DDR register, that is 00. That means all the 8 bits should be 0. So the whole port will become as an input port. Now here the port B is working as the output port. So we need to send all the ones to that particular port B in data direction register. So in the second instruction, that is out DDRB comma R16. That means the data of R16, that is FF, is loaded into DDRB register. So the B port will now work as an output port. Right, now what we need to see is we need to give some data. Right, so what we is LDI R16 0x55. So here we have taken one data 0x55 and we are giving this particular data to the output port, which is port B. So the fourth instruction, that is out port B. So sorry, that is a E written. So that is not E, that is the port B. So out port B comma R16. So the port B is now loaded with the data, that is 0x55. Right, so 55 will be loaded in port B. Now what for first data we have loaded? So we need to call that delay. Right, so till now we have not studied about the delay. So simple, we will write that call delay instructions. Right, we will study the detail how to make the delay loop after the 2 sessions. Right, so now call delay. Right, so we have called the delay of somewhat seconds. Now after calling the delay, there will be a delay loop, and in that there will be instructions for that particular time interval, how much delay we need to calculate, and that last instruction in that particular subroutine, that will be a return. So it will return that particular instruction to the next instruction, which is again LDI R16 0xA. Right, so what does that will do? AA is the complement of 55, right? So we have loaded AA in R16. If the data is not known to us, we can use complement instructions, in which we have discussed in the logical instructions, right? So we can also use complement R16, right? If we don't know the data, what is in register data, right? So instead of LDI R160XAA, we can write directly instruction which is COM R16. So directly it will complement the data of R16. Right? So R16 will have the data 55. When we complement that particular data, it is nothing but A, right? So 0XA. Now the next instruction is again 0 out port B, again is port B, not port A, port E, comma R16. So after the complementing the data, the A will be transferred to that port B. And again we need to call that delay. So we will call this delay, that is called delay. Right? And last instruction, that is the rjump L1. So it will be continuously moving, and the continuously 55 and AA will be displayed on port B. So there will be a continuously toggle of data of the port B. Clear? So this is all about the program 1. Now let's discuss the program 2. So what is the statement of program 2 says? Write a program to data present at the pins of port C. That means we need to take the data from the port C, right? So port C will be input port for our process controller, and send it to port B indefinitely. So port B is the output port for our program. After adding the value 5 to it, so when whatever the data comes from the pin C, that is the input port from C, right? We need to add 5 to that particular data, and the result will be sent on to port B, which is our output, right? So what first we need to do is we need to declare port B as an output port and port C as an input. So as you can see in the solution, the first instruction, that is dot include M32 def.inc. This shows that it is the directive, assembler directive, which we have discussed, and it will show that it will include all the libraries of ATmega32, right? So it will include the libraries of Mega32, and the programmer can know that the program written below, that is for the ATmega32, right? So that is the directive shown here. Now for the first instruction, we need to declare port C as an input port. So we need to load DDR-C register with 0x00. So the first two instruction, as you can see, LDI R16 0x00 out DDR-C, R16. So 0x00 will be loaded in R16 in the first instruction, and the R16 data, that is 0x00, will be loaded in DDR-C. Then second, that we need to implement that port B as an output port. So we will again take the data in R16 0x0 0xFF, that means all port are 1, and then R16 data will be sent to DDR-B. So in the first 4 instructions, we have declared port C as an input port and port B as an output port, right? Now what we need to do is we need to take data from port C, and we need to add this data with 5, and then we need to give the output on the port B. So as you can see, we have taken the data from port C, so it is an input port, so in instruction will be used. So in R16 comma pin C, so from the input ports, that is C, pin C will be used, and the data will be taken and will be stored in register, that is R16, right? Now we need to add this data with 5. So again 5 will be stored in some register for using this add instruction. Add instruction have a syntax between the two general purpose register. So the LDI R17 comma 5. So 5 will be loaded in R17. Then add R16 and R17. So the data of R16 and 17 will be added, and the result will be stored in R16, which is our right hand operand destination register. Then that particular data result is in R16. So R16 we need to send in the output port, which is our port B. So out instruction will be used. So out port B comma R16, and we need to do this indefinitely, that means continuously. So we have used this last instruction, that is rjump L2, right? So L2 is label. So the continuous the data will be taken from pin C. 5 will be added to that particular data, and that data will be again the result will be displayed on the port P, right? So this is all about the program 2. Now next, that is program 3, right? So what does this program 3 stands? So an LED is connected to each pin of port D. Write a program to turn on each LED from pin D0 to D7, right? So all the pins should be turned on one by one. Call a relay routine before turning on the next LED. That means once if D0 is blinked, then there will be some delay, then D1 will be blinked, D2 will be blinked, similarly at that particular time till D7 will be linked, right? So as you can see in this program, dot include, again M32.def will is included, right? Here what we have taken, we have registered, we need to call this delay, so we need to implement this stack pointer. So using LDI instruction, we are implementing stack pointer higher and stack pointer lower. So these first 4 instruction, that is LDI R20 high, out SPH R20, and LDI R20 low, out SPL R20. So we have implemented stack pointer as an address, right? So now what we need to do is we need to make port D as an output port. So again the R16 or R20 is loaded with FF, and that will be sent to DDR D register, right? Here in place of port 0 there is a port D, right? Just make sure it is a printing mistake. Now what we need to say is we need to on this particular LED. So we need to just on, or we need to set, for on we need to set. The set instruction will be used, set bit SBI, right? Port D comma 0. That means the first bit of D, that is D0, will be set. Set will be, it will be implemented, I mean, it will blink down, right? Then we will call some delay. So call delay. Then port SBI port 1, port D comma 1, right? Similarly we will generate all these instructions using this SBI port D comma 3, 4, 5, 6, and 7, and in between these instructions we will call some delay. So the call delay will be used, right? Now that's all for today's session. Here we have seen that basic examples related to instruction set, as well as how the IO port programming, or how to make input and output port of port A, B, C, or D, right? And also we have seen that how to two instructions SBIS and SBIC, and we have seen the related programs related to it, right? So that's all for today's session. Thank you for watching.